Turn and engage. I'm not going to lock your screens today, but if you may want to just turn your monitor off just for so you're not distracted. And later in the presentation, we will actually do the examples, so I'm going to have you guys engage with that. But we've now started this unit on variables. Okay, and I want you guys to just tell me what you've learned from part one, and just anything about variables. Just before you do, remember I did this in part one, and if we go back, you guys said things like, oh, okay, variables come from math and science. There are these things that represent things. There are things that change. We then kind of said, well, in computer science, you know, what variables kind of are in that process. But what do you recall from part one in terms of variables in computer science? Go ahead. They store info. Absolutely. How do they do that? Like, so what are they as related to the computer? There's different types. Okay? That's a little different than math and science. In math and science, you don't really define them that way. So when they store info, it's like a piece of the computer's memory, right? It's a chunk of memory that you're using. What else do you need when you create a variable? You need the type, but what else do you do with it? Right? So if I say like int, that defines the type, then what do I put to make a variable? Then name it. Yeah, the variables have a name. Okay, for sure that they have a name. We know that names have rules. You can't break those rules or it won't allow it, but they also have a certain style. You can break the style, but other programmers are expecting it. Style would be things like camel casing and always starting in lowercase letters and stuff like that. Rules would involve things like you can't name it a reserved word and you can't use a number at the start. You don't have to have those all memorized, but as you get used to using them, those just kind of fall into place. But what about types? What have we learned so far about types? Okay, what would have been the couple types you've used so far? I gave you one, integer. What else? Double. What else? String, yeah. And then there was a couple that kind of weren't used that much, the long and the float. Kind of, I said push those aside. So right now we just kind of have those. Double, that's a weird D. Double, string, and integer. And kind of I've already went over that. I said that's also kind of what you do is if it's text, you use a string. It's the only type you need. If it's a number, you got two choices, integer and double. An integer is just short to int because computer scientists are lazy and they don't like to type more than they need to. You'd think double would be shortened as well to like, you know, they don't want to do that. So there we are. Okay, so you guys have learned a lot from the first part. Then there was a couple more little specifics, right? Especially if you did the example or you started doing the two problems. There was stuff like converting, this convert, okay? And then there was this thing where you draw things out of a text box and then you put things back out into a label. And you're kind of getting used to the way that sort of style of code exists. If that makes sense to you, what I've shown here, you're already well on track with this unit. You're well underway. Okay. There's an error communicating with the Juno Tower. Oh no. Hang on one sec. Okay, so today let's take a look at part two and what I have for you. So let me dim up the lights so that it sets the mood in here for you guys. Now, is this thing not working? Okay, so as we saw in part one, a variable in computer science is a way to store data, okay? It's defined as a piece of memory that has a name and holds a value, okay? That name actually defines a location, like a mailbox, an address. It says this is where it's going to be and this is what it's going to hold. So here's the format, right?
Interruption for all period 3 teachers that were expected to have vaccination students.
Okay, so here is the name of the variable, and then in the first part is the type, and we saw that, and then its initial value is 0. Okay? And already you've learned a few data types. There are actually more than I've shown you, and I'm going to show you the rest today. The question you're going to have as a programmer is, what type do I use? Well, it depends on what you're storing. So let's see how you guys do. Okay? So if you're going to store that, an age, what data type do you think it should be? Yeah, integer. Okay? It's a round number. Age, we don't usually define our ages as decimals. Maybe you guys still do. I don't know. Did any of you say you're like 14 and a half? Did any of you still go with that? When did that stop, by the way? At what age did you stop using halves? Like about 8 or 9, really? 'Cause my daughter doesn't do that anymore either. But at one time you did. You said, I'm 4 and a half, right? I'm 5 3/4. But then it stops. Trust me, I don't usually say I'm 45 and a half. It just doesn't come out of my mouth. I usually don't even say that I'm 45, right? But there you go. Okay, so this would be a larger number, right? If you're dealing with Big Macs at McDonald's. Could you go something bigger than the integer? I said not to use it, but do you know that it exists? What is it? Anyone remember? The long, yeah. So temperature, about 1 decimal place worth of precision. Double, okay? Now don't make me regret the fact I didn't lock your screens. Okay? Measurement. Now let's say this was 205 and the 5 was repeating. If we needed more precise than floats, double, right? So, and I think I mentioned this here as well, that these two are kind of the same thing, integer and long, and float and double are kind of the same thing. So let's not overcomplicate things. Just always go with double and always go with integer. Okay? But what about this one? Right, a string. And now I can show you that there are others. So for example, what if it was simpler than a string? And even simpler than an integer? Something that was so simple, really it only had 2 values. Like this. True or false. Well, in that case, there is a data type designed for that called the Boolean variable. The Boolean variable has only those 2 values, true or false. It is the simplest of the data type. But in programming, this is going to come up a lot, is where you need to store whether something is true or false. For example, there's all kinds of different scenarios in programming where you might need this. Like if you were making a game, alive or dead could be basically true or false for a character within a game. And if you make it a Boolean, it's extremely efficient because it takes up so little memory. It only basically needs a 1 or a 0 to store. So as a result, because it takes up so little memory, it'll run faster when it uses it. The Boolean is probably one you're not going to necessarily use. You won't need it for the programming problems, but you should know that it exists. And as your programming gets a little more advanced, this might become something that you will incorporate. For example, I see a lot of students often incorporate this into their final projects, even though it doesn't necessarily come up in assignments. Okay, so if you're using a number, really you've got 2 choices, integer and double. Long and single, maybe, if you want to get a little more specific. If you're using characters, you go with string. And possibly, if you really need it, some sort of true-false thing, you use Boolean. Which, by the way, they also shorten down to just the word bool. But there are more. Okay? The C# language actually defines several more data types that are either a little more advanced or are just literally unnecessary because they're just more specific. So for example, there's one called the byte, which is an even smaller version of the integer that only goes from 0 to 255. There's the S byte, okay? That stands for signed byte. And then there's the short, the unsigned short, or the U short, the unsigned integer, the unsigned long, the decimal, and the char. Char actually only holds 1 character. It's like a string that you're only allowed to hold 1 thing. Out of all of these, the only one that I anticipate you might ever actually need would be the last one, the char. The rest of them are so specific. Only if you were writing software that was that specific about that amount of memory usage would I ever recommend using those. Because you could use integer or double to do the same thing and basically still be okay with your memory usage. Okay, but know those exist. I'm not hiding them from you. Those are built into the language of C#. Now that doesn't mean that these are necessarily going to be in other programming languages. They might not. There's a lot of similarity between C# and other languages, but they're not exactly the same. Okay, now, before I talk about this, okay, one of the other things we did about variables, storing information, types, name, converting, is variables are useful for formulas, and you knew that from math and science. So does anyone know how to get area of a circle? Does anyone know that formula? What is it? Right, and this is how your math teachers would write it, right? Pi r squared. Okay, now that's a math formula or even a science formula. So if we were to convert this into computer science, we wouldn't put A, we'd put area. We wouldn't put R, we'd put radius. We couldn't make it squared, but we could do radius times radius. That would be the same thing. But what would we do about that? That's a variable too, isn't it? Or is it? What would your math teachers call that? Don't say pi. I know it's pi. But what would they call that? A thing? They've never used that word? The proper word for it? It's a constant. Okay? It's a constant. Why? Does it ever change? Is pi ever going to change? This is going to change, right? That one's going to change, but pi's never going to change. What is pi? Like, what's the value of it? It's 3. How many decimal places do you guys know?
1415926.
That's pretty good, actually. I'm actually shocked you guys got that far. You could go more, right, though? You know there are more. How many more?
It's irrational.
It's infinite, right? Why don't we just write that here? Okay, so why don't we write as much as we know? You guys knew this much. Why don't you write that? No, let's be honest. You're lazy. Yeah, you're lazy. You just don't want to write it. You write that because it's easier, right? You're lazy. So computer science is the same way. Why don't we write something that makes it constant? And that's what I'm going to introduce to you. You can create these in computer science as well. Constants are essentially variables that don't vary. So they just lock in and they don't ever change. Okay? Now, we also need a style to write this. Because in math and science, they actually have a style. They use a weird symbol. Why don't they just use a P there for pi? Because you'd think it's a variable, right? You'd think it changes. So they use a symbol that represents something that kind of looks a little bit different. That's a Greek symbol, right? So they use a Greek symbol. So we're going to change the style so that we can recognize, that's something different. But in computer science, we can't type Greek symbols easily. We can, but even with our keyboard, it's a little bit trickier. So they've altered the style slightly. Okay, so this is what a constant is. A constant in computer science is just a variable, but it's a variable that doesn't vary. It doesn't change. To create this, what you do is you create a variable as normal, double pi equals, but at the front of it, you put the keyword const. The second you put that keyword in, it now locks that variable, so it can't change anymore. It locks it down. So at that point, you can't change it to be like, on the next line of code, say pi equals 5. It would say, error, this is a constant, you can't change it. Okay? As far as the style goes, the way it works in computer science is the constants are typed in all capital letters so that it stands out, and that's why I yelled it, so that it really stands out in your code. So if I jump back here, what the style would be in my code would be all capital letters. Pi times radius times radius. This would now be the equivalent of the same formula in computer science, right? It's a little more typing, yes, because we're typing and not writing, but it's the same idea. So when you look at this as a programmer, you go, okay, that's a variable, that's a variable, that's a constant. How do I know? Because it's written in all capital letters, and it stands out for me that way. So that's the way you can create these things, okay? You create the constant, and now you can't change it, but you can use it for calculations. It's a lot easier now in your code to write pi, if you were doing it several places in your code, than actually typing that giant value in all the time, okay? So one of the reasons you use constants is it makes your life easier as a programmer. It's for lazy people, okay? And lazy is good. But that's not the only reason constants are used. It's not just because you're lazy. It actually makes your code more efficient. And more efficient means it will eventually run faster. For the programs you're writing now, that's not a big deal, because they're probably going to run just fine. But think about it. As the course progresses, you're going to get more and more knowledge, and your programs are going to get bigger. And then how fast it runs will become an issue, especially if you get to your final project and you want to make something like a game. You want that thing to be running at best performance. So if you start coding now the right way, it'll be easy when you get down the road to just incorporate that in. If you don't do it now, and then you get to your game and you're like, Mr. Watts, why is this running so badly? Well, you should have used the constant here, and you should use the constant here. Well, how do I do a constant? Well, now you're going backwards in your learning. So that's why I'm introducing it now. Get in the good habit now of doing it while it doesn't matter, so that when it does matter, it's easier. Sometimes coders call these magic numbers. They're these numbers that just appear in formulas and we just assume that they're something, right? So it also improves the readability of your code. It makes your code easier to read when you see the value pi rather than just some weird number showing up in your code. It makes it faster and it's easier to update code. So here's an example. Let's say you wrote a taxes program for your parents so they could do their taxes. Let's say that was your final project this year. I know, not that exciting, but let's say you did it because you wanted to earn favor for your parents because they were thinking about buying you a car, and then this sort of turned the corner and you got a car for your birthday next summer. Okay? So you wrote this program and you put in there the tax rate for Manitoba. But instead of making a constant, you just typed the number into your code. But you had to do that in like 70 places through all the code you were writing. Like it was a big program. So in 70 different places, you typed in the tax rate. And then you gave it to your parents and said, here's the program to do your taxes. They go, this is great, except the Manitoba government just changed the tax rate. You're like, oh, crap. You got to go back into your code and change every single place you put that number in. But if you were a smart coder, you would have started at the top of your code and made something called tax rate and put a constant in there. And then any place you needed it in the formula, you just put that in there. Now how many places would you have to update in your code? One, right, exactly. Work smarter, not harder, right? The smart coder knows that they can be lazy, but they are incorporating this stuff within their code, okay? So the constant at first will seem like you're wasting your time doing it, but it's about me building good programming practices within you, okay? The style again is to use that uppercase to lowercase. Now, the uppercase style. So it's harder to do two words then. So how do I do refund code if everything's in all caps? Well, now is the place where you can use the underscore. Now the underscore makes sense. So that's why I said don't use it for regular variables, because we were holding on to it. So now we can use it for things like constants. So constants stand out to you. But if you want that constant to describe what it's doing, use a underscore to separate it as needed. Okay? And they can be in any data type. So notice this is a double constant, a string constant, a float, a Boolean, an integer. The other thing you need to know about constants is when you create it, you have to give it a starting value. It doesn't give you an option not to. With variables, you have that option. I said don't, but you have to give it some sort of value because it needs to know what am I going to be forever at this point. Okay. The next thing I want to talk about is this idea called scope. And this one is a bit of a tricky concept. So some of you might miss this if you're not careful in watching this. Scope essentially refers to where your variable is considered alive. Okay? Where it exists within your program. So obviously, when you start up a program and you create a variable, it exists, right? You take a piece of memory. But the second you shut that program down, like you stop C#, or you log off, or you pull the plug on your computer, that variable no longer exists, right? It disappeared out of memory. But was the variable always in existence for the whole program? This is what's called the scope of it, okay? The scope of a variable is basically where it is alive inside of those curly brackets because they define the scope of the variable. When you create a variable inside of something like a button, which you would have done in the last example, or if you did the temperature converter or the dog age calculator, that's what you did. You put the variable inside the code for the button. So it's said that that variable only exists within that button. The second that button stopped being clicked, the variable stopped existing. This is what's called a local variable. It's just local to that button. So here's an example, right? Here's, say, I have a button called enter. Don't worry about it. Let's just say there's some program with an enter button. And within that button, I make a variable for text. and I make a variable for an integer. These two variables, text and number1, only exist within these two curly brackets. So they exist at the moment that button's being clicked, but by the time the code gets down to this bracket, the computer goes, I'm done with them, and it wipes that memory out. It's no longer needed. Okay? So here's where the variable's declared or created. Here's where it's actually used within another variable. And it is only alive within that scope, within the scope of those two curly brackets. That's its scope, or its actual existence is within there. So when it gets down to that curly bracket, those two variables essentially die right there. They no longer exist to the computer. Okay? But sometimes you don't want that. Sometimes you want a variable to exist more than just that. For example, let's say you have multiple buttons, and all of those buttons want to use the same variable. Or what if you want the variable to be alive for the whole program, like it never disappears? If that's the case, you want what's called a global variable. So there's the local variable, and now there's the global variable. To create a global variable, you create it near the top of your code under the line that says public partial class. And we're going to do this in the example today. Okay? All right, so let's do this. I need you guys to build this simple design with these simple names. Okay, so you have your design. Here's mine. I did mine big on purpose just so it's easier for you guys to see, obviously. So there it is. There's my design. Text box, and then down here's a label. Obviously, clicking these buttons is going to take something in the text box, do something to it. You can probably guess what it's going to do to it, and then display the answer down here. Okay? But it's the way we code it that's more important than the actual getting it working. Obviously, I think a lot of you could probably get it working right now, but that's not the point. The point is we want this to be coded in a certain way. So here's the first variation we're going to do. Rather than double-click these three buttons, which we will be doing, I want you to actually double-click the text box. Okay? So what happens is you can actually also put code in a text box. What this means is, now you don't actually click a text box usually. Well, I mean you do, but what this code by default says is, at any time something in the text box changes, what should I do? So this is happening all the time. So imagine you type the number 47. So the second you type 4, it'll look at this code. And then the second you type 7, it'll go to this code. So it's going to be going to this code a lot, okay? Not like with a button where it's different, like that's happening once. This is happening a little bit more often. So we want to have something happen there. But before we do, what I want you to do is scroll up your code to the top of your code, well, near the top, okay? Now up here is code you normally don't touch, okay? And by far you shouldn't. So there's this thing here. You don't want to touch that. That's basically code that C# writes for you that builds your design up for you. So obviously you don't want to mess with that. This stuff up here is stuff you don't want to mess with. And as well, this one is stuff you don't want to mess with, right? This thing here. If you take my grade 11 course, I go into the details of what all this stuff means in more detail. But this is the area where we can also create variables. You can also create variables under where it says public partial class, but after this opening curly bracket. So I'm going to leave some space right there. Okay, and you should as well. Up here is the area that you can create global variables. So these would be variables that are available to anything. So for all three of our buttons, if I make a variable up here, all three of my buttons can use it. As well, variables up here are alive for the whole program. So until you stop the program from running, these variables will always be alive. So let's make one up here. Let's make a string for the text, and we'll just start it off as a blank string. So it has nothing in it other than just some empty quotes. Okay? Oops. So this variable now called text is available to all my stuff. So now I can go down here to this thing here, and I can say text equals txt input, dot text. Now, the reason why I can do that here is if you think about it, this is what you would do for your button. You would say string text equals, you'd read the text out of there. But you'd do that for all three of your buttons. So this just made this a lot easier. I'm just doing this now all the time. The second they type something into the text box, I'm storing it. So if they type a 1, I'm storing the 1. Then they type a 2, I'm storing a 1 and a 2. If they say 1, 2, 3, I got 1, 2, and 3. Like it's always remembering everything you type in that text box. All the time. Okay? So now let's go back out to our design and double click add to. Okay? So now we've got the text stored. Okay? So down here in add to, what if I wanted to take that and turn it into a number? Well, I would do something like this. I would say int number equals convert dot to int 32 of the text. And for those of you who've done the example or the first two problems of the variables unit, this code will look very familiar to you. You've probably done this. We did it in the first example. If you did the dog age calculator, you probably did this, although you didn't call it number, you probably called it something like human age or something like that. But you've done this before. It converts the text, and now I know what text is. Notice that it didn't give me an error saying, what's text? I have no idea, because it's a global variable. Since it's global, this code sees it, this code sees it, everybody sees it. It's alive. So then what would I do? Well, I've got to add 2 to it. Okay, well, I can do that. But this is a weird thing. If you just do this, number plus 2, you'd think that that would do it. But that's not the way it's written in computer science. That's too vague. You think, well, I just put the semicolon blocks. That's all you were missing. No, obviously not. The way it works in computer science is you write it more like this. Number equals number plus 2. Okay? That's the way you write it. Because what that means is you're adding on to yourself, right? This is, again, a little more specific. You don't normally write this in math class. You may. You might want to say like x equals x plus 5. But you might just say x plus 5 and assume that it's adding 5 to it. Well, we don't make assumptions in computer science. We write the code that it's more specific. This means whatever number it was, add 2 to it, and now that's what it is. Okay, so it's I don't want to over-explain it, but you're going to see code like that a lot in computer science. Okay, now let's put it out in our label. LBL output dot text equals, oops, okay. Now, some of you may have realized that this is not going to work if you ever try code like this. You can't put a variable that is a number directly into the text of a label. It doesn't allow that. Because again, it's very specific. It's like, hey, I need you to be text. And that's not text, that's a number. So there's been a couple ways we've resolved this problem. Some of it is we take a piece of text and combine it, and then it's like, okay, now I'm happy. Now you've given me some text. But a few of you actually figured out there is another way to do this. It's kind of a little bit fancier. But there's actually a way you can do a conversion with this convert. I'm just going to show you. You don't need to type this, but there's a way to convert to a string. You can go back to a string if you want to. Okay? I think that's a little more complicated than you need to do. To be honest with you, all you need to do is give it a piece of string and combine it with the number. And you know what that piece of string can be? It can essentially be nothing if you want. It can be what's called a blank string. So this is a way, that's way easier to me, is you just say, okay, it's going to be a string and attach that number to it. Oh, okay, then it can do it. All right, so let's run this super exciting program and see if it works. So I type a number, 12, and I add 2. Yay, it worked. It added 2. Okay, so done. Now let's go write add 4. How would the code be different before I type it? Would it be different? Would it be the exact same 3 lines? Well, almost. What would change? Yeah, the 2 would change to a 4. So let's do that. Let's just copy the text, or the code, the 3 lines. and change the 2 to a 4. Now, let's not even run it. We'll assume it works. But for a second here, let's look at these two pieces of code and think, hey, is there something inefficient about these two pieces of code? I can say that there is. In this add to button, I create a variable called number and convert the text. And in this one, I create a variable called number and add to. Why am I doing that twice? Why couldn't I have done that up here when I inputted it into the text? In other words, what if I took this line and moved it up here? And yes, in C# you can drag and drop code. Then I wouldn't need it down here, and in theory I wouldn't need it down there. So, now, that reduces the amount of code I'd have to type, so that might be an argument that that's going to be more efficient. So let's do that. I want you to copy and paste that line up here, but it's going to cause 2 errors. Well, a couple errors. But that's okay, we'll let the errors go for now. So now our add2 just has number equals number times 2, and our add4 has number equals number times 4. Then we still have the line to output it. That still exists. Okay? But what's the problem now? Can anyone figure out what the problem is? Why is number causing a problem down here? I'll give you a hint, one word. Scope. Where does the variable number exist? Where is it alive? It's created right here, which means it's only alive between this bracket and that bracket. So in other words, down here, it has no idea what you're talking about when you mention the word number. It doesn't exist to this thing, this button, add. There's no idea. How could we resolve that? Make it global, right? This is a local variable. The way we're using it is if it's a global variable. So let's fix the code. Here's how we're going to do it. Okay, by the way, is anyone behind here? So just take out the int part right now. Now even this one is confused. It's like, well, I don't even know what this thing is. And now go up to the top and create a second integer called number and just start it off at 0. Now we have 2 global variables up here, the string of text and the number. And now look, all our problems are fixed. All of our problems have gone away. And now let's test it. So 12, add 2, add 4. By the way, did you notice what happened? I think it went maybe too quick for you guys to realize. Watch again. I'm going to run it again. See if you can notice this subtle thing. 12, add 2, add 4. What happened? It added, yeah, I know it added 4. But what did it add to? Did it add it to 12? No. It added to 14. In other words, the answer remembered what it was. Watch, if I add 4 and again, it adds 4 to what was already there. It adds 2 to what was there. So it's not really adding 2 to that anymore. It's adding to because it's a global variable, it's always remembering what it was. It didn't reset. Yes? What was the second one? Okay. So yeah, I may have gone a little bit quick there. So let's start at the top. For those who have missed some of the code, at the top of your code, you should now have just these 2 lines. String text equals this, and int number equals 0. Okay? Inside of the text box, you should have those 2 lines. Okay? Notice I don't say int number anymore, because number is a global variable, text is a global variable. Okay? So those 2 things are inside the text box's code. Then inside the 2 buttons, I just have number equals number plus 2, label equals that, so it's a lot simpler. All right. Now you can probably guess how we're going to code that last button, but before you do, we're going to do one more thing. This is a bad example of it, but I want you to go back up to the top of your code. We're going to create one more global variable. An integer called double, or double it, equals 2, but at the front of that line, I want you to put this, the word const. Now, hang on, I'll just zoom in so you guys can see this thing closer. So this is a constant. Okay? So in other words, this variable will be available to anyone who wants to use it. But you can't change it. It's 2, and you cannot possibly ever change it from 2. Now, I get it that it would be way simpler to just type a 2, but we're practicing here, right? So the style with constants is at the front of the line you put the keyword const. That instantly locks this thing. You don't have to type it in all capital letters. It would still be locked, but good style should say, if I type it in all capital letters, it'll stand out to me. And since I'm using all caps, in order to separate 2 words, I use a underscore to do that. Okay? So now, here's the challenge. Write the code for the last button using this constant, and write it right now. I'm going to do the same, but I'm going to lock my screen so you can't see me type it. And in about 2 minutes, I'm going to reveal the answer, and those who get it right are going to give me an air high five. Write the code for the last button. Double it. Try it. See if you can get it working. Yes. Just 1 sec. If you need me to come over, I'll just be 1 sec. Just so you know, I'm done. Prepare yourselves. This is the code for double it. It's about to appear on the screen. For those who got it right, prepare to give me the air high five. Nice. So it's just the same. It's number equals number times. Now it would be normally times 2, but here we incorporate the constant, double it. Okay? It's not the best use of a constant, but it shows how this is something that you can incorporate. Okay? So this is a very simple example of constants and global variables. Chances are you're going to need to incorporate one or both of these into the next 2 programming problems. Okay, so this all exists in the notes as well. So just to show you guys. In the notes, for those of you who missed the example or aren't here today, if you're not here today, listen to me. Listen to me, those who aren't here today. That's a joke. The code is in the notes, so all that code's in there, so you can get it out of the notes if necessary, if you ever lose it. Okay? So it's there. Now, the last thing I want to talk about today is something else that you're going to now need to start doing in your code. Okay? Now that you're not beginners anymore, you need to know that there's something that exists in code called comments that we're about to look at. Comments are not code that the computer looks at. So in other words, comments are not things that run when you run your program. But you type them into your code as little, exactly what I said they are, comments to yourself to explain how code works and to give clues to other programmers how code works. They have no effect on how the program runs. But they are part of the programming world, that comments exist within code. Okay? So what C# does is it ignores comments. They're just there for programmers. Here's how they work. I want you to put these into your example. So into your example, we're going to go up to the top where we had those global variables, up here, and we're going to put a comment. You can put comments on a line by themselves. So that's what we're going to do right now. So right there where my flashing cursor is, we're going to type a comment. The way you type a comment so that it knows it's a comment is you put these 2 slash characters. The second C# sees those 2 slash characters, it knows everything after this will be a comment. Also, it'll color code it green for you so you can see that. So this is a comment. Okay? That's how you do it. Now, you can put comments on a line by themselves, like I just did. But as I said, everything after that character becomes a comment until it moves to the next line. So you can actually put comments on the same line as code, as long as it's at the end. So here you can see I've put a comment on the same line as code. This is now useful to you. You can start leaving little notes to yourself. Especially in things like examples, you might want to make a note that, hey, this is a global variable, right? So you know what that is in your, okay? You may want to make a note that this is an example of a constant. Right? And you can write it in whatever language you want because you're not writing code, you're just leaving yourself a little comment. Okay? So those are called comments, and they're super useful to you, especially in the learning process, to put in your code. Now, if you guys ever advance in programming to eventually become a professional programmer, they're going to expect these. Because you often don't just write a big program by yourself. So you often leave comments for other programmers like, hey, Bob, this is the code I was working on Friday. It's broken. Can you fix it for me, right? Those are the things you sometimes do. But you got to think even beyond that. Sometimes you have a piece of code that might not be working. Here's a common mistake I often see students do. They'll accidentally capitalize the T of text. I see that a lot. Students will accidentally do that. And all of a sudden your line of code, or let's say they didn't do that, they misspelled it. Text, right? And they get an error. And what I'll see a lot of students do is they'll take that line of code and delete it trying to fix the error. And that's fine. But you may realize later, oh, I shouldn't have deleted that line. I should have just fixed it. Well, why not just take that line and temporarily make it a comment, then keep working, and then later come back to it, remove that little thing, and then it's fixed again. And you didn't have to retype the whole thing. Yes?
Can you show the code for the button bubble?
Sure. Okay. So that's what comments are useful for. They're useful for leaving yourself little notes, leaving others little notes, and actually in the debugging and the fixing process, you can actually use comments to help sort of remove code without really removing it. And actually, I'll show you a little trick that the IDE has built into it. The IDE has built into it a couple tools on the toolbar right here, just below the saving. Near the end of this bottom line, these last two buttons here, right there, are specifically about comments. And let me show you how they work. Because I often see students do this. Let me go back up to here. We're down to this line here. So they want to remove both of these lines. So they think, oh, well, why don't I just make each of these a comment? So they go, do this, and then they go down to the next one and do that. And then later, and let's say there was 10 lines. They went and did that 10 times. Then later, they want to go bring it back. So they go move that one, they go here, remove that one. Well, obviously, C# realized programmers do this a lot. So what they made is you can highlight 2 lines or 3 lines or 300 lines of code and click that button, and it just makes it a comment. And then click the button beside it, and now it's not a comment. This allows you to do what's called comment out code and comment in code. This is when you have a broken piece of code, you can just highlight it with your mouse and click it to get rid of it temporarily, and then click this one to bring it back. Handy sometimes, a handy thing. Okay? So this is a piece on comments. Okay, so comments, again, do not affect the way a program runs. They have various purposes for programmers to include notes to yourself, but as well, it's a way to sign your code. Like as if you sign your essay written by, Dave Smith. So comments allow you to put your name into your code, right? So you know who wrote it and when you wrote it and maybe why you wrote this code. So that's important. It also sometimes leaving yourself notes like, oh, this code was tricky, right? So this is what happened here. And it helps to sort of explain what's going on, okay? All right, here's the bad news. Comments are now part of the mark you will receive from assignment 3, not 1 or 2, assignment 3 of the variables unit on to the end of the course. So I am now going to be expecting you to put comments in your code. How much? How much comment? Do I have to comment every single line of code? No. Okay? You can. You'll never get marked for over-commenting code. Okay? But if you put no comments in your code, a portion of your mark, not all of it, but a portion of your mark will be lost. I'll go over the marking on a different day. Okay? So actually what I'm expecting, here's what it is, this green idea. Okay? So we've seen this already. What I'm actually expecting is a comment at the top of your code, somewhere near the top of all your code, before you hand it in, that has this on it. So for every programming problem you do, I'm expecting your name. Don't put generic student. You're better than that. You're better than that. You want to put your real name in there. And no, you don't have to put name. You can if you want to. You can just put your actual name. The date. Now, date can be loose. You can just put like spring 2015. That's fine with me. It doesn't need to be the exact time and date. This is useful to you, especially if you go on in computer science. You can go, gee, when did I write this piece of code? Oh yeah, it was in the spring, right? Put my name down. There's a reason for that too. I won't go into that too much today. Put the assignment down, like, oh, this is variables 2 or whatever, and a general description of what it is. And again, I'm not an English teacher. You don't need to write me an essay. Just one line saying, like, this is a dog age calculator or something like that. You do not need to do this for assignment 1 or 2. You can, but it won't affect your mark because it's not in the marking. But it's starting at assignment 3, I am now expecting this. Okay, so I know we're almost